What if everything we know about the age of the universe is completely wrong? Right now, it looks like modern science may be facing its greatest crisis in over a century. For decades, astrophysicists have studied the cosmos using the Standard Model of Cosmology. It's essentially the master mathematical blueprint of the universe, and it's used to accurately calculate how fast the universe is expanding. But when Nobel Prize-winning astrophysicist Adam Riess turned the James Webb Space Telescope toward the depths of space, something unexpected happened. In the most distant regions of the universe, Webb discovered an anomaly that could overturn modern cosmology. It revealed that the universe is expanding significantly faster than the Standard Model predicts. If that's true, then one of our most fundamental ideas about the cosmos may be seriously flawed. For the first time in decades, the core equations of modern cosmology no longer match reality. Adam Riess and his colleagues are now openly saying that the Standard Model may not tell the whole story. Somewhere in the depths of space, an unknown mechanism appears to be influencing the expansion of the universe, yet it remains completely beyond our understanding. And if this is confirmed, scientists may have to rethink almost everything we know about the cosmos, its age, its history, and even its ultimate fate. But this cosmic crisis is only the tip of the iceberg. Webb's latest observations suggest that we never truly understood how the universe works. The telescope has discovered the ancestors of supermassive black holes that formed in ways that completely defy current models of cosmic evolution. It captured violent torrents of energy that were literally killing galaxies in their infancy. And most recently, while studying our cosmic neighborhood, James Webb detected something on the mysterious interstellar object 3I Atlas that no telescope had ever been able to see before. So what exactly did humanity's most powerful telescope discover? Why is the universe behaving so strangely? And could this mean that the ultimate fate of the universe is far more terrifying than anyone ever imagined? By the late 1920s, American astronomer Edwin Hubble, while working at Mount Wilson Observatory, noticed that distant galaxies were rapidly moving away from each other for no apparent reason. And the farther apart they were, the faster they fled into the abyss. This meant that something invisible was causing the very fabric of space itself to continuously stretch. It was then that we first realized we live in a universe where most of it remains hidden from us. If you could shrink our entire universe down to the size of an ordinary house, then everything humanity can see, touch, or measure, from a grain of sand on Earth to giant stars, would occupy just one small room in that house. Everything else would remain hidden in darkness, locked away by the laws of physics that, as it turns out, we still don't understand. But we kept searching for the answer. 100 years later, scientists, among whom Vera Rubin, Saul Perlmutter, and Brian Schmidt played particularly important roles, along with entire research teams including the Planck ESA mission and the WMAP NASA Observatory, developed a new model of the universe that today looks more like an unsolved puzzle. Everything that makes up us, the planets, and the stars is visible matter, accounting for a modest 5% of the cosmos. The remaining 95% is the greatest mystery. About 27% is dark matter, an invisible cosmic glue that keeps galaxies from flying apart under their own gravity. The remaining 68% is dark energy, a fundamental property of space itself that causes the universe to expand. Scientists decided to calculate one precise number, the rate at which this force is pulling the universe apart. They call it the Hubble constant. To calculate it, astrophysicists developed two independent methods. The first method can be described as a look into the distant past. It was carried out by scientists working with the Planck Space Telescope. They used one of the oldest signals in the universe, the cosmic microwave background. It is the faint thermal echo of the Big Bang, the oldest light in the universe traveling through space for 13.8 billion years. The Planck telescope did not observe galaxies directly. Instead, it mapped the entire sky in the microwave spectrum, creating an incredibly precise map of the tiniest temperature fluctuations in this ancient light, a kind of fingerprint of the young universe. Each of these tiny fluctuations is the imprint of future galaxies, concentrations of matter and gravitational fluctuations in the early universe. This is where the key part of the method begins. Scientists compare this pattern of the cosmic microwave background with a physical mode of the universe, where the laws of gravity, the density of matter, and dark energy are known. They then adjust the parameters of the model until the computer simulation perfectly matches what Planck observes. And once that match is achieved, the model automatically produces one precise number: the current expansion rate of the universe. The result was unambiguous: 42 miles per second or 67 kilometers per second per megaparsec. To understand the scale, 1 megaparsec is 3.26 million light-years. That means for every additional megaparsec of distance, galaxies move away from each other 67 kilometers per second faster. For example, two galaxies separated by 2 megaparsecs are already moving apart at 84 miles per second, and it keeps increasing from there. The second method of calculating the expansion rate is a direct look at the present. Astrophysicists decided to measure how fast the universe is expanding here and now in the local universe, using the so-called cosmic distance ladder. And no, not this kind of ladder, but rather a chain of physical measurements where each step is based on the previous one. A key role in this approach was played by astronomer Adam Riess, leader of the SHOES project, who significantly improved the cosmic distance ladder method and made it one of the most accurate tools in modern cosmology. Scientists find special pulsating stars in nearby galaxies called Cepheid variables. These stars are unique. There is a distant direct relationship between the period of their pulsation and their true brightness. This allows them to be used as standard candles. The principle is quite simple. If you know how bright a star really is and compare it with how dim it appears from Earth, you can calculate the exact distance to its galaxy. From there, this ladder continues. Cepheid variables allow scientists to calibrate typeless supernovae, which in turn are even brighter cosmic landmarks visible across enormous distances. This is how the expansion of the entire observable universe is measured. For years, this work was carried out by the Hubble Space Telescope, and its direct measurements of the local universe produced a shocking result of 45.3 to 44 miles per second per megaparsec, noticeably higher than the value obtained from the cosmic microwave background. The difference between the two results was about 8 to 9%. At first glance, this may seem like a minor discrepancy, but for modern cosmology, it's an enormous gap. Imagine two doctors weighing the same person. One gets a result of 154 pounds, the other almost 168 pounds. Both are using properly calibrated scales and well-tested methods. In this situation, the question is no longer about the numbers. We need to understand why two reliable methods of measurement are telling two different stories. This is exactly the situation cosmology finds itself in today. The two most accurate methods of measuring the universe produce two different answers, and no one knows why. Scientists named this mysterious conflict the Hubble tension. The last hope of researchers, including Adam Riess, was the assumption that the instruments were to blame. Scientists hoped that the old telescope was simply introducing a systematic error. All the hope of the scientific community was placed on the James Webb Space Telescope. Equipped with its enormous gold mirror and ultra-sensitive infrared instruments, Webb is able to see through cosmic dust and clearly distinguish one star from another. NASA pointed it at the very same galaxies and the very same Cepheid variables that its predecessor had studied. Astronomers expected Webb to solve this problem, but NASA's publications and scientists' reports from 2023 and 2024 turned out to be extremely unexpected. The James Webb Space Telescope found no errors in the Hubble Space Telescope. Its observations precisely confirmed that the direct measurements of the local universe are correct and that the expansion rate really is 45.3 to 44 miles per second per megaparsec. There were no errors in the instruments. The 9% discrepancy is real, and this turns the Hubble constant into a new cosmological crisis. It means that the universe is not expanding the way our standard model, based on Albert Einstein's theory of relativity, predicts. We're missing something fundamental. And the harder scientists try to reconcile these two methods of measurement into a single answer, the stronger the feeling becomes that the problem is not just the expansion rate, because behind this discrepancy lies something even more fundamental: time. In the standard cosmological model, based on data from the Planck satellite, the universe is approximately 13.8 billion years old. But if the local measurements made by the team of Nobel Prize-winning astrophysicist Adam Riess are correct, and the Hubble constant is indeed closer to 45.3 to 44 miles per second, then the universe may actually be 1 billion years younger. The difference may seem small, but on a cosmic scale, it already suggests that the entire evolution of the universe may have followed a different path than the one we consider standard. And if we truly misunderstand the history of the universe's expansion, then an even more disturbing question arises: do we really understand its future? Cosmologists, including Catherine Freese, one of the foremost experts in cosmology, particle physics, and astrophysics, believe that if mysterious dark energy continues to dominate the cosmos, then the most likely future of our universe is the scenario known as heat death. And perhaps it's the most merciless ending that modern physics allows. Over tens of billions and then trillions of years, space will continue to expand. One by one, galaxies will disappear beyond the cosmic horizon, forever losing sight of one another. Light leaving one of them will never reach another. Gradually, the last stars will burn out. No new ones will ever be born. The once bright universe will become an endless ocean of darkness, where the few remaining islands of matter are separated by unimaginable distances. Space will become so empty that even a chance encounter between two atoms will become an almost impossible event. It will be the end of absolutely everything. The very concept of time will simply lose its meaning. There will be nothing and nothing left to happen. The deeper we try to understand the nature of the expanding universe, the more necessary it becomes to look back to where it all began. But when exploring the early universe, we must be prepared for the possibility that it contains objects and processes beyond the limits of our current scientific understanding. During one of its deep surveys of the cosmos, the James Webb Space Telescope captures light that has been traveling toward us for more than 13 billion years. A signal from an era when the universe was only a few 100 million years old. In a single image, 45,000 galaxies were captured, stretched across the depths of time, where the tiniest points are the earliest proto-galaxies, only just beginning their existence. As NASA scientists examined them, they noticed something strange among these galaxies. Their red color means that their light has been shifted far into the red end of the spectrum due to the expansion of the universe, which means these objects are at an enormous distance from us. According to NASA scientists, they already existed just 600 million years after the Big Bang. But what caught the attention of Seiji Fujimoto, an assistant professor in the David A. Dunlap Department of Astronomy, and his colleagues, was something else. Their luminosity turned out to be unexpectedly high, far too bright for objects that should have existed only a few 100 million years after the Big Bang. The first assumption may seem obvious. These are young, the very first galaxies to form in the universe, slightly chaotic in structure and extremely active in forming stars. But this explanation was quickly ruled out. The formation of a galaxy is a lengthy process. Primordial gas must cool, collapse under gravity, and go through several cycles of star formation. That takes an enormous amount of time. Yet these red dots were already shining brightly at a time when far too little time had passed since the Big Bang. Even more surprising were estimates of their mass. On average, they're hundreds of millions of times more massive than our Sun. In other words, we're looking at a very bright and very massive object that strongly resembles a galaxy, but one that existed at a time when galaxies like this simply should not have had enough time to form. Further study of these objects by an internal team of researchers, including Spanish astrophysicist Pablo Arrabal-Aro, revealed something remarkable. The instruments detected unusual behavior in the light coming from one of the red dots, designated Glimpse 17775. Instead of escaping the object freely and traveling into open space, the light was literally bouncing around inside the object. Pablo and his colleagues suggest that this effect is caused by the object being surrounded by an extremely dense cocoon of partially ionized gas and cosmic dust. Its density is enormous, thousands of times greater than that of a typical galactic environment. As a result, as the light tries to escape, it is scattered over and over again within its shell, as if reflecting off it and losing its direct path. This led researchers to the hypothesis that at the very center, beneath this layer of gas, the deadliest object in the entire universe may be hiding, a quasar. Just imagine an enormous supermassive black hole like Gargantua, the one you saw in the movie Interstellar. Now multiply its energy many times over and you get a quasar. If the word rage had a physical form, this would be it. It is an active, ultra-bright core of a young galaxy where a supermassive black hole is devouring the surrounding matter at an incredible rate. The material it cannot swallow spirals around it and forms a gigantic accretion disk, accelerating to nearly the speed of light. The gas heats up to millions of degrees due to extreme friction, causing this single monster to shine brighter than an entire system of 1 billion stars. These are simultaneously the most massive and the brightest objects in the entire universe. Even from a distance of 2.5 billion light-years, space telescopes can capture them in incredible detail, as in this image. But because of the incredibly dense environment, all of that light cannot simply escape. The surrounding gas absorbs the energy, completely blocking the blue part of the spectrum and allowing only long infrared wavelengths to emerge. It is this dusty disguise that transforms a quasar into the tiny red dot in these images that puzzled scientists. One of the authors of this study, astrophysicist Vasily Kokorev, states that all of their calculations agree and that this is the most likely case. These mysterious red dots are the first massive black holes in the universe. But the greatest mystery lies in the origin of these monsters. Quasars are born and grow at the centers of galaxies. So how could these supermassive black holes have appeared shortly after the birth of the universe, if massive galaxies had not yet had time to form? The answer proposed by the scientists may surprise you. It seems that the early universe lived by completely different rules than it does today. Today, for a black hole to be born, an event on a galactic scale must occur: the explosion of a giant star, a supernova. Its brightness can outshine even its own galaxy. At the site of that explosion, a black hole is born, and over billions of years, it slowly consumes its surroundings and grows, becoming larger and more powerful. But at the dawn of time, this rule may have not applied. Data obtained, in particular from the James Webb Space Telescope, suggest that the first supermassive black holes may have formed directly without any supernovae. They condensed from enormous clouds of ultra-dense primordial gas, appearing directly at their centers and then actively consuming them. Over time, they gained more and more mass, influenced the surrounding gas with their gravity, helped shape the future galaxy while continuing to grow themselves. It creates the impression that the universe was breaking its own rules of evolution, creating massive black holes before their own host galaxies had time to form around them. Very recently, while continuing to explore the young universe, the Webb telescope discovered another incredibly powerful and ancient force. Colossal torrents of raging energy that were literally killing the first galaxies in the universe while they were still in their youth. To launch the assembly line that creates billions of stars, a young galaxy needs one essential resource: cold hydrogen gas. At the dawn of the universe, this building material was abundant. It would seem that the first galaxies should have flourished for billions of years, but JWST observations revealed something completely different. Inside many galaxies, stars suddenly stopped forming. Galaxies were dying at the peak of their youth. This strange phenomenon is being carefully studied by a team of astrophysicists led by Rebecca Davies, lead author of the study from Swinburne University of Technology in Melbourne. While studying an ancient galaxy called Crystal 02, they decided something unprecedented: a devastating galactic hurricane. This is not just a cosmic wind in the usual sense. It's a colossal, ultra-dense flow of cold molecular gas erupting from the very heart of the galaxy at speeds of hundreds of miles per second. Its kinetic energy is enormous. If our Earth, or even the entire solar system, were caught in the path of this raging flow, its atmosphere would be stripped away in a fraction of a second, and all life would be instantly erased and destroyed by the immense pressure. Rebecca Davies compared the dense regions of the early universe to bustling megacities. In these cosmic cities, galaxies constantly collided and merged, triggering insane bursts of star formation. Everything operated at maximum speed, following one principle: live fast, die young. But the accelerated pace became a death sentence for Crystal 2. Because of the extreme density at the galaxy's center, millions of massive stars were born. Their rapid burnout, followed by a chain of supernova explosions, created monstrous shock waves. This internal storm swept up the hydrogen and hurled it into deep space, twice as fast as the galaxy could turn it into stars. The cosmic megacity was literally blowing itself apart, losing its fuel with no chance of getting it back. According to the researchers' estimates, at this rate of gas loss, Crystal 2 could die within 50 million years. And all of this we observe with a delay of 12.8 billion years, as if we were watching a recording made in the depths of time. Perhaps today this galaxy has long been dead or radically changed, but its present does not yet exist for us, because its light simply hasn't had enough time to reach us. However, sometimes danger does not come from the depths of space, but literally flies right past our home. Do you remember last year's major sensation, the mysterious object 3I Atlas that arrived from beyond the solar system? Recently, the telescope managed to detect something on this object that no telescope had ever detected before. Right now, 3I Atlas is approximately 900 million miles from Earth. It has long since left the inner solar system and is currently passing the orbit of Saturn. By the early 2030s, the comet will completely leave our solar system after crossing the heliopause, the boundary beyond which the solar wind can no longer reach. After that, it will begin its journey through interstellar space. This summer, in 2026, using the mid-infrared instrument, Webb directly detected methane on an interstellar object for the very first time. This discovery surprised astronomers. Methane is an extremely volatile gas that should have evaporated long before the object reached the Sun, but this visitor managed to preserve it. For billions of years, methane ice remained securely sealed deep beneath the comet's surface crust, protected from radiation. Only when the heat of our star finally reached its core did these internal reservoirs become active. Powerful jets of gas erupted from deep inside the comet. Webb's data revealed anomalous proportions. The amount of methane and carbon dioxide is several times higher than in any comet formed in our own solar system. According to researchers' estimates, this chunk of ice may have formed 10 to 12 billion years ago. If those estimates are correct, it means that perhaps even the very star system where it originally formed no longer exists. It's hard to believe, but we've been given the chance to observe and partially study a comet that may be as old as 87% of the entire age of the universe. For us, Comet 3I Atlas is a unique time capsule, and it has clearly demonstrated that chemistry in other star systems may operate by rules different from our own. When this interstellar visitor made its closest approach to Earth in December 2025, the internet literally exploded with panic. People seriously discussed the threat of Armageddon. But its trajectory toward Earth was in the safe zone from the very beginning. The same cannot be said about another space object that carries a real, calculated risk of colliding with the Moon, or even our planet in 2032. We're talking about asteroid 2024YR, which is traveling in an orbit around the Sun. In the astronomical community, objects like this are known as city killers. According to precise scientific estimates, this space rock is about 200 feet in diameter, roughly the size of a 15-story building. Despite its seemingly modest size on a cosmic scale, this monster possesses tremendous destructive power. In the event of a direct impact, it could instantly destroy an entire city, leaving nothing but a giant crater and a scorched wasteland where millions of people once lived. We previously released a video about this object on our channel. Even back then, mathematical models developed by scientists showed an alarmingly high risk of a collision with the Moon in 2032, 4.3%, setting a historical record in the entire history of observations. Then came a complete blind spot. The asteroid passed directly behind the Sun. Because of the Sun's intense glare, ground-based radar systems and conventional optical telescopes completely lost sight of it. It was believed that new data on the object's trajectory would not be available until 2038, when it would approach Earth again 2 years later and become observable. But in March of this year, the Webb telescope managed to track the city killer. Positioned at the unique L2 Lagrange point 930,000 miles from Earth, Webb detected the asteroid's faint thermal signature, effectively ignoring the blinding sunlight. It captured this image on February 26, 2026. In the image, the asteroid is highlighted in green, while the red line shows its calculated trajectory determined by scientists. Detecting such a small object was already a difficult task, but an even greater challenge was its extremely low brightness. NASA specialists at the JWST Observatory ironically noted that the asteroid reflects about as much light as an almond would if it were placed at the distance of the Moon. Its brightness is approximately billions of times fainter than the dimmest stars visible to the naked eye in the night sky. All of this highlights just how sensitive the instruments aboard JWST really are. The critically important data resolved all remaining doubts among NASA specialists and eliminated the errors in the previous calculations. The updated orbital model delivered the long-awaited result. On December 22, 2032, asteroid 2024YR will pass at a distance of approximately 13,200 miles from the Moon. The risk of a global catastrophe has officially been reduced to zero.